These, you're supposed to show that they're inverses, and to do that, you're supposed to show they obey this property, that if you compose them f with g, you get the same answer as if you compose g with f, and in both cases it works out to just x. And when I say that, it can't be absolute value x, can't be 2x, can't be x plus 2, nothing else but just plain x, although it could have a restriction on it. So, the first one's nice and easy. I say that, but you got to be careful. So we'll do f of g. There's f, plug g in like so. And what I'm saying is, I expect you to do show the work properly. This work, I need to see the proper order of operations. In other words, you can cancel the 4's first. And then once that's gone, you get x minus 9 with a plus 9, and then the 9's 0 out. What I'm saying is, I need to see the correct order here, because people mess this stuff all the time. They just wave a magic wand on it and make it work out when it doesn't, because they don't really know what they're doing. And so I expect you to do it in 2 steps, like I did. Cancel one thing, rewrite it, and then do that one. That way I can tell which one you did first, because order matters here. Now going the other way, G looks like this, and then put F right there. And what happens first this time? The 9's 0 out. Okay? You cannot just cancel the 4's as your first step there. And then after the 9's 0 out, the 4's cancel out, and you're good. Because it did work out the same and worked out to x both ways, and you can say, therefore, F and G are inverses. Okay? Now, the next one is similar, on the same point. It's just, we have to deal with domain restrictions. So this one's going to be trickier. All right, so let me set it up first off. I'll do F of Gn. Now, before we start this, let's put the identities up here again. This way is absolute value of x. If you do square root first, then it cancels to be just a, except for it can't be negative. Okay? So here, that's just going to cancel. And you'll just be left with 4x minus 32. Except a can't be negative. Basically, I recommend actually, just before you even start this, go and write down the domain. So you can't let that be negative, and so basically you can't let x be below 8. Move 32 over, divide by 40, that's where you got the 8 from. And that's exactly the restriction we need here. So just write it down. So basically when you set it up, if you just put the domain as the inner function, and that gets you to it. And then, like I said, that cancels, leaving that there. Now you can divide everything by 4 here, so you get x minus 8. And you just get x. But once again, it's tight with this restriction. But that's okay. That counts. Since that worked out to x, we have to work the other way. So we do g of f. So here, g looks like this. Put f in there. And once again, I would write down the restriction on the inner function. And here, that had to be given. If they took that off, you wouldn't even have an inverse, would you? Because you'd have a parabola, and like a whole parabola. With that restriction, you do have something that has an inverse. Now, right here, tell me what I messed up on. I'm going to distribute the 4, and get x squared. Where did I mess up? Yeah, and just don't make silly mistakes like that, please. And 32 0 out, so you get this, which does not equal x, it equals absolute value of x. But once again, bring along that domain restriction. So look, once again, if this restriction was gone, we'd be stuck, because we just have absolute value of x, which isn't x, and they would not be inverses. But, and watch this, just to make it clear, if I do absolute value of x, I get this. If I draw y equals x, I do not get the same thing at all. But in actuality, they are the same part of the time. When? On the right side, yeah, for x's that are not negative. So this is what's true. If x is not negative, then absolute value of x equals x. You can replace absolute value of x with plain x only if you're not talking about negatives, which means this does equal just plain x. But once again, only because we had that restriction on x. And if you look at the graph, this is a parabola shifted up 8 with the compression, but I'm just sketching the parabola, but it's only the right side. And this was the square root function, which, by the way, it shifted right 8. I know it's hard to see that, but this is what you see on the graph. They are a reflection of line y equals x. I didn't draw it perfectly, but it is a reflection. Just for the record, by the way, if you wanted to see the shift right 8, if you write g in this form, you can see the shift right 8. Okay, so it really is, they are inverses. Okay? And I have to say again, the tricky part is knowing how the restrictions were necessary for the algebra to work out like they did. Okay? Because they change it. All right. We're going to do 36, but I'm going to come back to it because I don't know, these take so much at a time, I feel. Let's do 50 next. These are nice and easy. Is 50 a function? Yes. Will the inverse be a function? Also yes. Look, none of the x's repeat, so it is a function. None of the y's repeat, so when I reverse it, which is all you do, here I'm writing the inverse right now. Just reverse all the x's and y's. The old range becomes a new domain. The old domain becomes a new range. And that is the inverse, and it's a function. So there you go. That's the answer. Make it a nice little table if you want. Next one. Is 52 a function? Is the inverse a function? No. It tells right there. You have y values repeat. We'd say it's not a one-to-one function, unlike the previous one. The first one, every x produces one y, so it's a function, and every y produces one x, or comes from one x, so it's a one-to-one function. This is not a one-to-one function, so the inverse, be careful. Notice how it says, does this exist? And the answer is no here. It's not saying there's not an inverse. There's always an inverse. It's saying there's not an inverse function. Okay? And that's a notation for an inverse that's a function. So like I could draw the inverse. I just swap with all the x's and y's. But it's not a function, so we don't bother. Here, actually, we're going to skip that. Let's do this. I'm going to go back, like I said, to 36 eventually. If I draw this, I'd have a parabola like this. It's a function, but does it pass the horizontal line test? No. If I draw a horizontal line, it hits 2 points, which tells me if I drew the inverse, it'd be a parabola, which would fail the vertical line test. So now it does say shape the domain range of the original, and then find the inverse function if it exists. So the domain range we still need to do. It's a parabola, so the domain is all real numbers. We shifted up 9, so the range is simply from 9 on up. But once again, the inverse function doesn't exist. So you don't have to worry about writing it out. This one, on the other hand, ones that look like this, they will have an inverse function. So let's get through it. Define the inverse. It was y equals, now it becomes x equals. And that becomes 8y plus 3, that becomes 2y minus 6. First step, I'm going to multiply with the denominator on both sides. So I multiply by 2y minus 6 on both sides. So the left side gains as a factor, the right side loses its denominator. We're trying to get y by itself. Once you get it like this, you want to simplify first. Let me do that. Distribute the x. And then I want to get all the y's together on one side, so I have a common factor y. So bring the 8y over, it becomes minus 8y. And I need to get rid of the 6x because, once again, I want every term on this side to have a common factor of y. Why? 7 factor out, good. and then you're there. Just divide by that, you have y by itself, which once again, once you successfully get y by itself, call it the inverse function, assuming it is a function, but it is. It looks like this. And really, that is it. You could actually factor the numerator and the denominator. The numerator, you can factor 3 out. The denominator, you can factor 2 out. But it doesn't gain you anything because nothing cancels. So you can express the answer either way. Now for the domain and range. On the original, the domain was easy. It's everything except 4. And the new one, the domain is also easy. It's everything except 4. 4. What's the original range? Every y value that's not 4. Yes. Because once again, the new domain is the old range, and the old domain is the new range. So once again, define an inverse, you swap x's with y's, which means the domain and range of the original becomes the domain and range of the new. But in a problem like this, if they ever ask for the domain and range of a function, what you do is you write down the domain of the original easily. You find the inverse so you can find the domain of that easily, and that new domain becomes your original range. Now, if I have time, I'll go over these, although frankly, I'm not going to be like something like that in the assessment, I don't believe. I really want to go back to do 36. You have to be able to get through this algebra. It's back to being where we have to compose them both ways. And if I make sure you label your work like I've been doing, this is f of g I'm doing right now. So g is going to go in place of f, or in place of x in f, both places. So 2x plus 6 over 1 minus x, minus 6. And then same thing here. 2x plus 6 over 1 minus x plus 2. Now to fix this, you can do it more than one way. I'm just going to multiply through by the denominator. And I'm going to distribute. When I multiply by the first thing, it just loses the denominator, right? I just cancel out the denominator. And then minus 6 times, and I'm just going to write that down for now. And same thing in the denominator. When I multiply times this, it just loses the denominator. And then plus 2 times that thing I just multiplied through by. I can squeeze this in here. This becomes minus 6 plus 6x. And then that's plus 2 minus 2x. What does the numerator add up to? Yeah. And the denominator, the x is 0 out, so you're left with 6 plus 2 is 8. Which means it does work out to x, which is good because that's what it's supposed to. Now let's say, if it says show that they're inverses, it will work out. Your job is to do it properly, okay? But they won't trick you. If it said, are they inverses, and if so, show it, or, determine whether they're inverses, but, then maybe they won't be, but they will be. All right, ready for the other way? Now g goes in place of x in both places. I'm sorry, f goes into g in place of x in both places. So we get 2 times f plus 6. And then, what is it, 1 minus x for the denominator? So put it there. This time I'll just multiply by x plus 2, top and bottom. Note that right here, that 2 is the numerator, so you might even write it as such, so you don't mess up. Here, when I multiply times the first one, the denominator cancels, and you're left with 2 times x minus 6, which I'm just going to leave as such for now. You can simplify it later. You can do it now if you want. And then 6 times that. The denominator, you get 1 times x plus 2 and then minus, and be careful, the x plus 2's cancel, you're subtracting that numerator. You need parentheses around it, in other words. All right, almost there. This is 2x minus 12 plus 6x plus 12, and then that's x plus 2 minus x plus 6. That's sign error. If you left the parentheses off, you'd have sign error right there. And then that's it. The numerator works out to 8x again. The denominator works out to 8 again, which doesn't always work out the same as in both versions. And there you go. It's done. And by the way, as far as stating your conclusion, you can just say, like I said before, f and g are inverses, or if you want, you can say g of x is the inverse of f, or f is the inverse of g. They're all the same thing. But that was the point of all that. All right, let's go back and do this one. Which one? Left or right? Right? Okay. I couldn't hear you. Quite right. All right, we'll do the one on the right. Okay. First of all, it's not a one-to-one function. When you restrict it, so it is. And this is at 5 because you can see it shifted left 5, right? So, so our function, after restricted, here, I'm going to just write it out with the restriction. And technically, if you let x be less than or equal to 5, you'd have a one-to-one function. I just don't want to use that restriction, okay? So now to find the inverse, swap x's with y's. By the way, what was the range of the original? Right? And then you can see from the graph. And what do we say? When you find the inverse, the domain and range swap places. And usually what we care about most is the domain restriction. I'm saying figure out the range of the original will give you the domain of the new one. Now, did I mess up somewhere? Yes. Okay, fine. No, you're right. You're definitely right. I would have figured it out eventually. Yeah. No, good. That was slow. All right. Simply, right here, right now, I can just replace that with that. Because what we already said before, if a is greater than or equal to 0, and when you're writing the identities, it's better to use something like a, not x. So if your expression is greater than or equal to 0, then we know absolute value of a is the same as a. That's the only time, right? Now, but if y is greater than or equal to negative 5, isn't y plus 5 greater than or equal to 0? So this is the right condition to allow me to just ignore the absolute value or rewrite it without the absolute value, because this rule applies then. If this restriction had been there, then you just couldn't do that. And so You get that, and basically you get, well, it becomes minus 1, obviously. I'm going to write it. It is a function. So move the 1 over, you get y by itself. If once you get y by itself, I'll call it the inverse function. Except if I do that, it wouldn't be right. I need the domain restriction. It's kind of hard to draw this thing. It's kind of weird looking. Something's off. Oh, that's why. I had it too far down. It went right there. That's right. This is going. The scale is off. It's not off, but it's going by 2s. So it looks kind of weird because it's just half an absolute value, and it is a reflection of the line y equals x. They're just parallel to that line. That's what it would look like. Once again, if you left off this restriction in your answer, you're wrong, because then you'd have the whole line. It's not right. It's only for that part of it. And just for the record, without the restriction, then the inverse would look like that. And it wouldn't be a function. That's why the restriction we put in there was necessary. Okay. All right. Are 76 and 78 the same thing? Not exactly. Here, let's see if we can do this quickly. Look, what is the opposite of squaring and then adding 1? Subtracting 1 and square rooting, right? So the inverse should be the square root of x minus 1. And here, the opposite of subtracting 4 and then square rooting is squaring and then adding 4. One of my answers is wrong. Well, the right one. There's something wrong with it. I need a restriction. This one is just the top half of a square root, right? On a parabola. Why? Because the y values are restricted to non-negatives. So this one, you need to put a domain restriction. Once again, we don't write that normally, but the fact is, the top one doesn't produce any negative y values, does it?
Okay.
All right. Oh, yeah. Okay. Good. Wait. Hold on. Let's slow down. You're looking at x values. So here, the x values are greater than or equal to 4. I agree. The y values are greater than or equal to 0. Yes? And I was after the domain restriction on the new one, so the x values would be greater than or equal to 0 here. So it's just the right half of the parabola. And then the y values here would be greater than or equal to 4. It's true, but you don't need to write that down necessarily. We definitely need the domain restriction, though. So we're supposed to compose these two functions. And that's what it says to do, right? So we're doing f, or g of f. So there's the f inverse inside of g. And by the way, just for the record, here, you don't need to write it, but the domain is everything greater than or equal to 1. When you cancel, you get x minus 1 sitting there, but with the restriction, which means the answer is x plus 3 with the restriction. If I had the calculator up and running, I'd plug this in. If you plug this in, you should see this line, but not the whole line. All right, see what happens with this. We're supposed to do g of f first. Let me just write that out. And just note the restriction on the inner. Nothing else we can do with that. So what is the restriction on, if I, square still can't produce negatives, right? I'm just going to write that down. So when we're supposed to find the inverse of this. So instead of y equals, yes, did I mess up? So that, I understand, but I'm using, I put the domain of the inner, is what I stated here. Basically, since you're right, the domain of this is, 4 and above, that means this can't produce anything above that. I mean, below that. We're going to go with it. Just write the domain of the inner, okay? And that's usually sufficient. Now we're trying to find the inverse of this. So swap x with y. And your domain range swap except for they're both 0. I mean, not 0, but non-negative. So when you swap them, this became your domain restriction, that became your range restriction. All right. Square both sides. What is that? I can fit it below it. And you get square root. But really plus and minus the square root. But once again, with these restrictions, it means it's really just the top half. You can't have any negative y values from this, so you can lose the minus part of it. Do those work out the same? Yeah. Okay. We'll stop there.